So consider influenza epidemics for two-parent heterosexual families. Suppose that the probability is 15% that at least one of the parents has contracted the disease, 10% that the father has contracted the disease, while 9% for the mother. What's the probability that both have contracted the disease? Okay, well, let me flip over to my notes, and I already wrote some stuff down. So I'm going to let A be the event that the father contracts the disease, B be the event that the mother contracts the disease, and I've written out, well, that the probability of A we were given was 10% or 0.10. The probability of B was the probability that the mother contracted the disease, and we were given that that was 0.09. And probability A union B, the probability that at least one of the family members have contracted the disease, is 0.15. That's this probability right here. Now we need to get the probability of A intersect B. Okay, so we have a rule that relates these probabilities to the probability of A intersect B. Remember that the probability of A union B, right, that's this, both these circles together, is equal to the probability of A, so we add that guy in once, plus the probability of B, so we add that circle in once, and then minus, we've added this middle part in twice, so we have to subtract it out. Probability of A intersect B. Well, now we can plug in. So we have, oh, that didn't help, there we go. We have 0.15 was the probability of A union B, 0.10 was the probability for the father, 0.09 was the probability of the mother, and probability of A intersect B was the thing that we want, the probability that both contract the disease. Well, this was equal to 0.19, 0.15 minus probability of A intersect B. And then if I subtract my 0.19 from both sides, I get negative 0.04. And then if I get rid of my sign on both sides, I get that the probability of A intersect B is 4%. All right, let me go back and check. I'm going to click 4%, and then I'm going to click submit. Yay!